playing field, said to me, you can only have an event like this large, one every 100 million years. And the one in Chicxulub was 65 million years ago, therefore you can't have another one. You could have 3 in 100 million years and not have any for the next 200 million years. So statistically, it's the same. You can't use that argument. Then they said, oh, we keep track of everything. We know where everything is now, which is not true, because since last year, 5 new comets, new asteroids, which they didn't have a clue about, appear, saying may be hazardous. So you can't use statistics to win an argument. Politicians do, but we know who they are. One other thing that Mark mentioned, about a year ago, there was a strange event in Peru. A crater had formed by a small meteorite, about a meter and a half in diameter. And this, according to the physicists, say this is impossible. You can't get a meter and a half object through the atmosphere and still retain a velocity that is sufficient to create an impact. And this was a beautiful impact crater, 15 meters across, 3 or 4 meters deep. So again, it happened. The evidence was there. It was real, but it was impossible. So we're in the sort of same scenario here. What we're saying is maybe this is thing, and other people are saying no, it's impossible, but it happened.
Just add one other follow-up too about the diamonds. One clarity there is almost all the diamonds we see did not come from outer space. They were formed on this planet. In fact, we find them inside these carbon spherules. Each one of these little carbon spherules, which averages about the size of the period at the end of a sentence, has more than 1 billion diamonds in them. Now, they're very small, but they're in there. So we were curious about how they could be there inside this carbon. So we reverse engineered the process, and we actually learned how to make them. We were able to create carbon spherules. They're made of tree sap, charred tree sap, and under the right temperature and conditions, we could create diamonds in them. It turned out to be so unusual that we have a patent application on it. No one had ever heard of this way to make diamonds before, but they're under such extraordinary conditions. They're not real-world conditions. It takes about 1,000 degrees C to form them, very intense heat. It's capable of, forest fires are capable of doing that. But the real key to making these diamonds is almost completely excluding oxygen. So if you have a steam atmosphere or argon or nitrogen, then the diamonds will condense inside the carbon, but without that, they actually burn up just like the head of a match. So we know how to make the diamonds. We're pretty sure how they were made, and what it requires is what we think are the exact conditions that would happen inside or very near the fireball of an explosion, an aerial explosion. That explosion eats up a lot of the oxygen, pushes the atmosphere aside, and it's almost a vacuum inside the fireball itself. And under those conditions, the diamonds can form. We've proven that in the laboratory. We've duplicated those conditions. We can make the diamonds. So we're certain that almost all of these diamonds were formed on the planet, and they were formed 12,900 years ago. Now, maybe if someone can come up with a better explanation for an impact, that's good. But so far, most of our critics say, well, that can't work, that can't work, that doesn't make sense, that's not good. But they don't come up with a mechanism. How do you get quadrillions of diamonds? Remember, there are 1 billion or more in the sediment the size of my thumbnail, and they're only under the block map. They're not in it, they're not below it, they're not above it. So my question is, if they don't like our hypothesis, what would be their suggestion on how this formed? This is extraordinary. We've looked through as much as 100,000 years of sediment from modern days back 100,000 years ago. There's nothing like this. So this is not something that's just going on commonly. Every 100 years or so, you have all this stuff forming. It's just not there. So if it's there, how did it get there? We're open to suggestions about how it got there. We don't think we've got all the answers by any means. But on the other hand, let's get past saying, well, I don't like that idea, or I don't think that happened. And let's get to the point, well, if you don't like our idea, what's yours? How did it happen? But don't dismiss it. It's so rare that it's not occurred but once in the last 100,000 years. And that's only as far as we've looked.
Okay, what I'd like to do is have a response now from the other side, as it's been characterized, and then I'd like to open it up to questions from the audience. I see that we have about 20 minutes left here, so I'd like to continue the interchange.
The information you just put out on the source of the diamonds is brand new, so we haven't really had time to fight back. Vapor deposition diamonds, is this something that you're homing in on, the technology used in vapor deposition diamonds?
Well, no, it's different than that. They seem to condense in the matrix of these spherules, so it's a carbon-rich matrix. They actually grow first as graphite, then under. What we find in this carbon matrix, it's amorphous carbon, it's dominantly carbon, a little bit of other things. And we find that for some reason, under the right conditions of temperature and anoxic conditions, that small domains of graphite will form inside these carbon spherules, given the continuing heat and not much pressure, it's atmospheric pressure, but it requires anoxic conditions, is for some reason, some of that graphite will go ahead and turn into diamond. And we've duplicated this under lab conditions. We can reliably produce diamonds as much as you want, under our conditions. The curious thing, as we found, is that the companies who are making activated carbon, do any of you have aquariums, or many of you take pills, these little packets in your pill bottles, activated carbon. Well, believe it or not, we found that the vast majority of that commercial activated carbon contains nanodiamonds. Almost all the manufacturers in the world are making fish tank carbon that contains nanodiamonds. They don't know it until we told them, and we're trying to get them to pick up our patent now. But the curious thing is, the key to their process of making activated carbon is you cannot let oxygen get into the process. They exclude oxygen completely. They keep your activated carbon in your fish tank. They keep it under steam conditions. In other words, they limit the oxygen, and these diamonds just condense right out of the carbon.
Remember I told you that we had proprietary information, and Alan's just let part of it out of the bag. I'm going to beg a little absence here and leave him to fight the other side. I have a hydraulic problem, and I'll be right back.
I think he says he really needs more coffee, not getting rid of it. Okay, well, this throws a new light on, and that's what scientific debate is all about. During last night's presentation, I got the impression that the diamonds were from the projectile itself. And here we're throwing out a different card, and no, you're accounting for one of your markers by incinerating in the absence of oxygen. In other words, you've got a giant charcoal kiln that's going full bore. That doesn't really offend me very much. We do see evidence for that kind of mechanism at the Cretaceous Tertiary boundary, and that is 65 million years old, not a little piddly 10,000 years in a geologist's eyes. So you would expect more fragile data to be able to survive. I'm a little curious about why do you call a radioactive bone layer an ET marker? Where does the radiation come from? What is